Hey T-Boy, what's up? Welcome to the stream. Hello. So this is my first live stream, so I apologize if it is a bit janky, but we'll see how we go. So I thought I'd just do a live stream and see if anyone needs any help with anything. Thought I could go through some questions. I know that the November paper is tomorrow morning, I think. So maybe we could go through some questions from the November paper from last year. But let me know if you're in the chat. If you want to ask any questions, feel free. We'll see how we go. Let's see. Let's put a question on the screen. Let's see if anyone's interested. If anyone's interested. All right. Thank you, Bilal. Thank you very much. It's a bit of a revision hour, homework hour. So it's kind of like, you know, if you're doing your homework, if you're trying to get motivated or you're stuck on something, feel free to ask. Send me something. You know, I always appreciated when I was at school if I had somebody to ask. Often my parents were, you know, busy or they couldn't help with my maths homework. So it was always nice to know if someone was around to help out. So thought I'd just do a quick live stream to see, you know, if someone's stuck on something, if someone wants some help with something, feel free to go ahead and send me a question, ask away in the chat, see how it goes. A-level papers. So I'm focusing on GCSE revision today because there's the GCSE resits tomorrow. So yeah. All right. Grade 9. Nice one, Dulay. Is that how I say that? Dulay? Queenan, wishing good luck. Thank you. I mean, I'm sure everyone appreciates that. Foundation, Seima, do you have any questions for foundation papers, or do you want to look at the foundation paper? We could do that. Let me know. Dollar. Okay, dollar. Thank you. Alright, so I have on the screen a higher paper from last year, and there's some questions in this we could look at. Oh, you mean a live stream of A-level papers, or just in general, like videos of A-level papers? Alright, Samar, which paper? The paper 1 from last year, foundation, or which one? Hey, what's up, Timmy? How are you? Hey, Ali. How are you? Hey, Malak. Welcome. Live stream of A-level papers. Yeah, sure. Can do that sometime. Good, Timmy, thank you. Foundation paper. Okay, let's have a look at a foundation paper from November last year. Let's see. Where do I have it? Okay, I'll just try to find it. November. Alright, let's see if this works. Oops, no, that's not what I want to do. Hey Burrito, no hero. Live stream of going through A-level papers. Could try it. Why not? I mean, I'm not gonna lie. There's A-level papers that are pretty hard, but we could give it a go together. Alright, let's see if this works. Oops. Alright. So this is a foundation paper, the paper 1 from last year. Malak, do you believe in the fact that some people's brains are built for maths while others find it easy to study English? Tricky one. What do you think? Hey Scrippo, what's up? Are you doing high or foundation? Hey Maybelline. Hey Ibrahim. Yes, all is well. How are you? Dan B. When you've already done your GCSEs. Year 11. Higher? Okay, so Samar was saying he wanted to look at some foundation questions. What sort of topics do you struggle with, Samar? I mean, we can look through this one. We can look at some questions and maybe just say, you know, we could go through some of these. Third paper tomorrow. Wait. I'm confused. Okay, some people are saying they want to look at higher stuff now. Everything about circles. Yeah, you have to be more specific. I mean, there's just so much you could talk about. Paper 3 calculator. I'm so confused. I thought it was paper 1 tomorrow. Proof questions on circle theorems. Yeah, I guess. I mean, can someone just clarify for me? Reset paper 1 tomorrow. Yeah, I was... Okay. Mocks. So you're... Scrippo, you're doing mocks or the actual GCSE resets? Okay, so circle theorems. Does anybody know how many circle theorems you need to know in GCSEs? Ritvik, you have some questions. Feel free to send them to the email on the screen. It should be on the screen. And I can pull them up. Yeah, some people are saying that they're doing mocks, but personally, I'm talking about the actual GCSE resets, which are in November. But there are mocks going on at the moment as well. This is, so on the screen right now is Foundation Paper 1. I also have Higher Paper 1, if you want to look at some questions from that as well. Yes, Ritvik, please send the photos and I can pull them up and we can have a look. And I'll do my best to answer them if they're, you know, to my best ability. Malak saying his mocks don't start till 3rd of December. Okay. Timmy, you're starting A levels in January. Okay. Cool, cool. Okay, sorry guys. I'm just a bit confused as to what to go through. Some people are saying foundation, some people are saying higher. Alright. So my original plan was to go through a few questions from the higher paper. So this one on the screen here. There are only green pens and blue pens in a box. There are 3 more blue pens than green pens in the box. There are more than 12 pens in the box. Simon is going to take at random 2 pens from the box. The probability that Simon will take 2 pens from the same color of the same color is 27 over 55. Work out the number of green pens in the box. Alright, so this is a higher question. obviously to do with probability. A1, I'd suggest work on the class in the class time, and then in your homework time, see if you can work ahead. Alright, so we're tackling this one on the screen. So we're told there are only green and blue pens. So let's say the green pens are, let's just call that G. Let's say the blue pens, well, we're told there are 3 more blue pens than green pens. So we could call this B, or we could call it G plus 3. Excuse me. And therefore the total number of pens, this is going to be G plus 3. That would be 2G plus 3, right? And we're told the probability that Simon will take 2 pens of the same color. So this is the probability of getting a green and a green, or a blue and a blue. This equals 27 on 55. Okay, so by the way, the reason I'm going through this is because it's almost guaranteed that there'll be probability questions coming up in these exams, in these GCSE exams. So it's really good practice to get your head around these before exams. Okay, next step. Would someone like to suggest what I could do in the next step? Anybody have any thoughts on what I could do here? So I've set up, this is my setup. I've introduced some variables for the number of pens, and they've told us the probability of getting a green and a green pen, or a blue and a blue pen. How could I represent these probabilities? Well, when I'm picking a green and a green, well, what's the probability of picking 1 green pen? That would be, yep, set up an equation, exactly, Malik, great. So if I pick a green pen, the total number of green pens is G, and the total number of pens is 2G plus 3. Now, what would be the probability of picking a green pen again? That's what you need to think about. Well, I've already picked a green pen out, so how many green pens left? Would be G take 1, right? And then how many total pens do I have? Well, I'd have 2G plus 3 take 1, because I've taken a pen out. So this would be 2G plus 2. Yeah, this more than 12, it doesn't really help us with the solving. It's more at the end of the problem, it helps you pick the answer, because we're going to end up with a quadratic. And when you solve a quadratic, as you know, you get 2 answers for the variable. So this more than 12, it doesn't actually help you with the solving of the problem. Okay, so this is the probability of picking 2 green pens. Now we need to add on the probability of picking 2 blue pens. So this is from the November 2018 paper 1, question 22. Okay, so we've said the number of blue pens is G plus 3. And the total number of pens again is 2G plus 3. We can multiply this by if we pick a blue pen out, we'll have G plus 3 take 1 blue pens, which will be G plus 2, divided by the total number of pens left in the box, 2G plus 2 again. Okay, so you notice these denominators are the same. And this probability equals 27 over 55. Alright, so that's the equation we're going to have to solve. Instagram. I don't have Instagram. But feel free, the email should be on the screen. If you do have maths, can you see the email on the screen? Should be down here somewhere. mathsexplained@gmail.com. Alright. Okay, so we're going to have to go ahead and solve this. Okay, so let's start by trying to simplify. We can multiply these numerators. G times G take 1 would be G squared take G. And this denominator here, well, treat that like 2 brackets, expand as you would normally expand 2 brackets. So use FOIL, so the first terms, multiply the first terms, 4G squared, the outer terms, plus 4G, the inner terms, plus 6G, and the last terms, plus 6. Then let's have a look at the second term in this expression. Let's try to simplify that. So again, it's like expanding double brackets. Multiply the first terms, G squared, outer terms, 2G plus 3G, that will be 5G, and the last terms will be 6 plus 6. Okay, and this numerator, the denominator will be the same here. So if we simplified this, we would get 4G squared plus 10G plus 6. And this is still equal to 27 over 55. Okay, how's everyone going so far? Alright, hopefully it's making sense. Next, again, because these denominators are the same, we can combine these numerators, or combine these fractions, and we can do G squared plus G squared would be 2G squared. Negative G plus 5G would be plus 4G, and then we have this constant plus 6. And our denominator stays the same, 4G squared plus 10G plus 6 equal to 27 on 55. So the question is, work out the number of green pens in the box. Okay, so we're trying to solve for G here. Oh, maybe you weren't talking to me. Alright. Yeah, it's a good question. Good practice. Next, you can divide the numerator and denominator by 2. So if I divide the top and bottom line by 2, I'm not changing anything, so it's okay. So I could change this to G squared plus 2G plus 3, and then divide the denominator by 2 as well. I'll have 2G squared plus 5G plus 3 equal to 27 on 55. If there's a simpler way, let me know. I can't see one, but maybe there is an easier way to do it. Ah, simpler than this. Okay. I mean, yeah, you don't have to write this denominator twice, but I don't know. Anyways, let's keep going. So next, I want to cross multiply. So because we have two fractions equal to each other, hopefully you know how to cross multiply. So if you had, say, 1 on 3 equal to 2 on 5, x. Say you had x on 3 equal to 2 on 5, you can cross multiply. 5x would equal 6, etc. So hopefully you're familiar with cross multiplying. So I need to multiply this side by 55. And multiply this 27 by this denominator here. And then expand these brackets. So 55 times all of this, 55 times g squared is 55g squared, plus 55 times 2, 110g, plus 55 times 3, 115. Sorry, 165. 27 times 2, that's 54 g squared, plus 27 times 5, that's 135 g, plus 81, 3 times 27. Okay, this is where it gets simpler. Remove the 6. No. So getting rid of that 6 yeah, it doesn't work. Alright, then we can simplify this. So 55 take 54g squared. That's just one lot of g squared. 110 take 135g. That would be negative 25g. 165 take 81. So that's what, 19 plus 65? 84 plus 84 equals 0. Great, Ahmed. Yes, send me a question, we can go through it, or we can have a go at it. Yeah, so when you have fractions with the plus, so if you have x plus 6 over y plus 6, this is not equal to x over y. So yes, Ibrahim is correct. Okay, now we have a quadratic that we want to factorize. So kind of difficult. We need to think of factors of 84 that will make 25. So let's try to think of factors of 84. Factors of 84, well, 1 times 84. What else? 2 times 42. 2 times 42 won't make 25. 3 won't go into, oh well, 3 will go into 84. It would be 3 times 28. Alright, no. And then we have 4 times 21. So 4 and 21 make 25. So we can actually factorize this quadratic. So our first terms are g and g to make g squared. We'll have 21 and 4. And then you just need to think of 3 and 28. Yes, player 1. Well, that would make 23 and 3 and 28 would make 25, except the signs would have to be different. So you'd have to have a positive 28 and a negative 3. And that wouldn't make a positive 84 here. So if we use 21 and 24, they can both be negative. Multiply those, and we get positive 84 and a negative 25. Alright. Next, to solve a quadratic, you take each factor. Say g take 21 equals 0 and g take 4 equals 0. So therefore g equals 21 and g equals 4. And now we need to go back to the question. Oops. This is where this more than 12 pens in the box comes in. So if there are 4 green pens, so if we had 4 green pens, we would have 4 plus 3 blue pens. That would be 7 blue pens, and in total we'd only have 11 pens in the box. So the answer of 4 green pens doesn't fit with this limitation they've given us of more than 12 pens in the box. So therefore there must be 21 green pens. So final answer there, 21. Okay. Alright, so I noticed some people saying that was the long way to do it, the more difficult way. But yeah, it works, so I think it's alright. It's logical, it makes sense. So the bottom line is you did need to end up with this quadratic here. This was the bit that you can't avoid. So as long as you get to this step, this g squared take 25g plus 84 equals 0, then you can answer the question. So these steps here, these ones in here, they might look a little bit different depending on how you tackle this problem, but you will end up at this quadratic however you do it. Alright, so yes, hopefully that made sense. Any questions, feel free to ask. Let's get on to this vectors question. Again, another pretty common topic in higher exam papers is vectors. So probability and vectors, if you practice those topics, you're pretty you're doing good preparation is what I'm trying to say, because you'll more than likely see those types of questions in the paper. Alright, so this question says, well, it gives you a diagram, a triangle, and it says OAB is a triangle, OPM and APN are straight lines, M is the midpoint of AB. Okay, M is here, so that means AM and MB are the same. OA equals A. Okay, so this is vector A. OB equals B. OP to PM is 3 to 2. Alright, so this is in a ratio of 3 to 2. Hey Lulius, am I saying that right? Lulius, welcome. work out the ratio ON to NB. Alright, there's an easy way to do this and a hard way to do it. What would you like first, the easy way or the hard way? The easy way or the hard way? Tips on your GCSEs: start early. Make sure you get a revision plan in place, so you're doing some homework every day. That's a good step. The easy way first, alright? Okay. Alright, so let's break down this diagram. I-list? Oh, okay. So we have a triangle here. M is the midpoint. These two lengths are the same, which means if you think about parallelograms, we can actually mirror this diagram and create a parallelogram. Which means M must be the midpoint of this parallelogram, because M is the midpoint of AB. So we can draw this line up to the corner. Let's call this point C. So we have created a parallelogram ACB. Okay, we'll do the hard way next. And again, as we're mirroring it, we can draw in this line AN on this side as well. Okay. So that means this line MC will be broken into the same ratio, 3:2, and we'll have some point here that extends, let's call this X, point X, which extends the line OM to OX. Alright. Now this line here, BX, will be parallel to AN. So these two lines are parallel. Again, because all I've done is flip this diagram over, I've mirrored it, so I'm acting as though I've placed a mirror on this line AB, and everything's the same. So this line will be parallel. That means that the angles are the same. So obviously if we look at, say, these triangles OPN and OXB, they will be similar. So these angles will be the same. Alright, so I'm going to use the idea of similar triangles here. So we can start by saying that this vector OP, which is the same as 3/5 OM, divided by this length ON, or vector ON, equals the ratio of OX over OB. Now OX is going to be 7/5 OM over OB. Why is it 7/5? Because again, this length here was split into the ratio 3:2. So this is 2 parts OM. So OX will be 3 plus 2 plus 7 parts, 7/5 of OM. Okay, so that's the equation you can create just by looking at this geometrically and using the idea of similar triangles. So these ratios are the same. Once you've got this equation, you can simplify it to get ON over OB as a ratio. So what I'll do here is multiply by ON on the right hand side and divide by this numerator 7/5 OM on the left hand side. So we'll have 3/5 OM over 7/5 OM equals ON over OB, which is the ratio that we want to solve for. Ahmed, yes, I can. I'll bring that up after I get through this. Now you can kind of treat this like an algebraic expression. You can effectively cancel out this vector here and say that ON, the ratio ON to OB, is equal to 3/5 on 7/5. If you simplify those two fractions divided by each other, or you flip the denominator and multiply, this will simplify to 3 on 7. So the ratio ON to OB is going to be, well, if ON out of OB is 3 on 7, that ratio is going to be 3 to 4. Okay, and that's the answer. 3 over 5. Okay, so yeah, when you have a ratio 3 to 2, that's 5 parts in total. So there's 5 parts. So if you're just looking at the part that's 3 parts of that ratio, then it's going to be 3 out of the total parts, which is 5. So you have to be careful with ratio and proportion. So that would be the fraction of the length. This is the ratio of the lengths. Thank you, Edward. That's really nice of you to say. Appreciate that. Okay, so that was the easy way, and you know, it's fine. It makes sense mathematically, but it may not work for every vector question. It's not kind of, you know, I wouldn't recommend it as a solid method to go into these. But you know, looking at vector questions geometrically like this can be a simpler way of doing them. Alright, so the hard way now. I'm just going to clear this off. So the answer 3 to 4, we'll get to that in a slightly different way. Alright. Let's see. Okay, this method involves finding AP and PN in terms of A and B. So firstly, we could start by looking at AB. This length over here, AB. That's going to equal negative A plus B. So how do we get from A to B? Using these vectors, we need to go negative A plus B. Then OM, let's turn the music down a little bit. OM will be, well, A plus half of AB. So vector A plus half of AB, which was B take A. So another way of writing this, if you simplify that, we'll have 1A take half A, which would be a half A, or a half A plus B. Okay, so that's what you get if you simplify that expression. So we have OM in terms of A and B. Now we want AP in terms of A and B. So we could say AP is negative A plus OP. Now we've just found OM in terms of A and B, so OP would be 3/5 of that. So we'll do plus 3/5 of, I'm not going to draw a bracket there yet, 3/5 of a half A plus B. Okay, so AP, we have an expression for AP in terms of A and B. Let's go ahead and simplify this. Negative A plus 3 on 10, A plus B. Okay. And then negative 1 plus 3/10. A would be like negative 7 on 10A plus 3 on 10B. Alright, so we have an expression for AP. Then the next part is to look for AN. So this whole vector AN. Why? Because that's going to allow us to solve for ON. Here. Okay, so we want to figure out AN. Let's start over here. AN, well, this is going to be some multiple of AP. Let's say some scalar multiple of AP. Let's call that X. XAP, because APN is a straight line. They told us that in the question. Also, AN must equal, well, if we start at A, we'd have negative A plus ON, which is a fraction of the vector B. So AN will also equal negative A plus some scalar multiple of B. So we have two expressions for AN. And now we can go ahead and set them equal to each other. So we have this expression multiplied by some scalar multiple we've called X. So this will be X lots of negative 7 on 10A plus 3 on 10B equals negative A plus K lots of B. And they're vectors. Okay, so then you can figure out what X is fairly easily because X times negative 7 on 10 must equal negative 1. So negative 7 on 10x equals negative 1. Here I'm equating the coefficients. So the coefficient of A must equal the coefficient of A on the right hand side. Then to solve for X, multiply by 10, divide by negative 7, we'd get X equal to 10 on 7. And then we have the coefficients of B. We have 3 on 10 times 10 on 7 equal to K. So therefore K equals 3 on 7. And remember, this was the coefficient of B for ON, this part here. So we can say, therefore, AN equals negative A plus 3 on 7B. So that means that this fraction here will be 3/7 of OB, or the vector B. Therefore, that ratio must be 3 to 4. Okay. So that's the other method. Which one did you prefer? The geometrical parallelogram method or the purely algebraic method of solving? I know this one's a more standard way of doing it, and it's more general, I think. it can be applied to more varied questions. But I still think there's a case for doing it the quick, simpler way when you see it that way. Okay, so 3 to 4 is the answer there. Okay, so we have a question. I think it was Ahmed. Let's have a go. Was this from the 2019 papers, I think? Maybe? Anyway, let me try to bring it up. Wait. There we go. Okay. Alright, so this is from, I think Ahmed? Yes, Ahmed. So this question says the ratio y plus x to y take x is equivalent to k to 1. Show that y equals x times k plus 1 over k take 1. Alright, let's see how we go. So my first step here, I think, would be to set up an equation. And, you know, if this is the wrong way to go about it, we'll start again. But let's see. So this would be intuitively my first step, to say that y plus x over y take x equals k over 1. And then try to make y the subject. So how can we make y the subject? Well, firstly, I would cross multiply. So I would say that y plus x equals k times y take x. I think I remember doing this question. And then expand the brackets. So y plus x equals yk, take xk. Then combine like terms. So y take yk equals negative xk take x. Then factorize y. So y, if I factorize y out of that, I'd get 1 take k equal to negative xk take x. And then divide by 1 take k, y equals negative xk. Oh, if I factorize that as well, I would get negative x k, well actually let's factorize a positive x out. I would get x multiplied by -1 take k over 1 take k. And then what I could do would be to multiply by -1 over -1, because clearly this isn't the same as this over here. So if I multiply by -1 over -1, it's the same as multiplying by 1, so you're not changing the expression, or you're not changing this fraction, but it just allows you to get this expression here. So then I would have x multiplied by k plus 1 over k take 1. Okay, so if Ahmad's still there, hopefully that helps. I don't see him chatting away, but hopefully he sees this at some point. All right. What else? Whoa. Okay, the hour's almost up, the revision hour's almost up. Ahmad, great, awesome. I'm glad I could help. Any other questions? Time flies when you're having fun. Save it? Yeah, sure. I'll post it. What do you think? Is this a good idea? Is this useful? More revision hours? Sure. Yeah, I'm looking to do more live streams. I think it's this kind of worked. You know, Ahmad sent a question in, and we were able to go through it, and it was helpful to him. So that was good, and we got through a few tricky higher questions. And maybe it helps with motivation sometimes. You know, it's easy to revise with a bit of help. I should have that A-level statistics and mechanics paper up tomorrow or Wednesday. Thank you, Says Brack. Appreciate it. Alright, I think I've harder ratio problems. I'll look for one in this paper. I'll firstly go through this surds question. A couple more questions before I end the stream. Danielle, this is my first live stream. This is my very first live stream on this channel. And you know, it's been a positive experience for me, so I'm looking forward to doing more in the future. GCSE statistics. Is that further maths? G Ruby? Do you mean in terms of further mathematics? Alright, so I'm going to tackle this question 20. Show that root 18 plus root 2 squared over root 8 take 2 can be written in the form a bracket b plus root 2 where a and b are integers. Alright, so this is a question where you need to rationalize the denominator. Suraj, let's talk about ratios in a minute. I'll try to find a question, then we can talk about some strategies. I agree that's a difficult topic. So let's go ahead and try to simplify this. Firstly, we want to expand out that numerator. And then we want to rationalize the denominator. What does that involve? That involves multiplying by the conjugate of the denominator there. If you haven't seen that word, feel free to Google it. That should explain everything you need to know. But the conjugate is essentially the negative of this term here. Or you want the negative of the square root term. So we'll have negative 2 take root 8. Oops, that's not equals to, by the way, sorry. That's multiplied by over negative 2 take root 8. So you can multiply by this because it's the same as multiplying by 1. And the effect is to get rid of this square root, this rational term in the denominator. And you'll see how that works in a second. Okay, so firstly I want to expand these brackets up here, these double brackets. Root 18 times root 18, that would just be 18. The square root times itself is just the number. Root 2 times root 18, I'll just write that as it is for now. Plus root 2 times root 18. Extra GCSE, okay. Yeah. Yeah, I guess that's in preparation for A levels. But yeah, we could look at some GCSE statistics maybe in another live stream. Then we've got root 2 times root 2, which is just 2. And this is still multiplied by negative 2 take root 8. Then on the bottom line we have these two expressions. And we can expand these out as we normally would. So negative 2 times root 8, that's negative 2 root 8. Outers is negative root 8 times root 8, that's negative 8. Inners, negative 2 times negative 2, plus 4. And the last terms here, negative 2 times negative root 8 will be positive 2 root 8. Okay, so hopefully you can see on that bottom line here, we'll have negative 2 root 8 plus 2 root 8. They will cancel out. So we've got rid of all the square root signs in the denominator. That was the aim. That was what we were looking to do. And then we're left with negative 8 plus 4. That's just going to be negative 4 in the denominator. Then we have to deal with all of this in the numerator. So firstly, let's simplify this part here. 18 plus 2, that's 20. Root 2 times root 18, that can be written as the square root of 2 times 18. So these are Surde's laws we're talking about. So we can say root 2 times root 18 equals the square root of 2 times 18. That will equal the square root of 36. And you should know what that equals. The square root of 36, that is 6. So this will be 6, this will be 6. So we'll just have plus, oops, yes, someone picked up that I have made a mistake somewhere. Or have I? No, I haven't. This will be the square root of 36. This will be the square root of 36. And so that will just be 6 plus 6, which is 12. And then this is still multiplied by negative 2 take root 8. 20 plus 12, that's 32. Multiplied by negative 2 take root 8 on negative 4. I could divide by 4 already, so this would be negative 4 times negative 2. Sorry, negative 8. Take root 8, which is equal to negative 8 times negative 2, that's 16. Negative 8 times negative root 8 is plus 8 root 8. Now if you look at this term here, root 8, let's just talk about root 8. That can be written as the square root of 4 times the square root of 2, which can be written as 2 root 2. So this term here can be written as 8 times 2, which is 16, root 2. And then if we factorize a 16 out of that, we get 16 times 1 plus root 2. Then go back to the question. We need it in the form a bracket b plus root 2. So in this case, a is 16 and b is 1. So that was for 3 marks for question 20. All right. Yes, I think the November papers are generally harder than the June papers. All right. Okay, ratios. Let's have a look. I'm not sure if there's a ratios question in this paper. Not 100% sure. Is everyone okay with proving recurring decimals algebraically? Hopefully. Yadoi. Oh, let's just jump back to that one. You don't have to write A and B, but you can say A equals 16, B equals 1. That's fine, but you don't have to. You just need it in that form. Alright, a ratios question. Oops, I'm going a bit fast. This is kind of a ratios question. Question 15. I think Suraj was asking about ratios. Is Suraj still there? Danielle, how come Hang on a sec. How come when you rationalize you done -2 take root 8? Oh, you mean why I wrote it like that? Well, you don't have to. You could write it like this. So let me just change it. So you could write it as -√8 take 2, -√8 take 2. So it was the same thing, I just swapped it around. As the main point is that you need the negative of the radical term or the square root term. Yeah, I don't know why I swapped it around like that. It just looked neater to me. No real reason. Sorry about that if that was confusing. Question 3 on this paper, sure. Question 3. Let's see. Alright, percentages. Alright. How many marks is this? 5 marks? Question 3? That's a bit mean. Okay, let's see. A bonus of £2,100 is shared by 10 people who work for a company. 40% of the bonus is shared equally between 3 managers. The rest of the bonus is shared equally between 7 salesmen. One of the salesmen says, if the bonus is shared equally between all 10 people, I will get 25% more money. Is the salesman correct? You must show how you get your answer. Alright. Okay, and this is a non-calculator question. So 40% of 2100 is what we're going to have to work out first. Let's do it this way. 40 over 100 times 2100. That's like 40 times 21. 840. Then the salesmen are getting 60%. So 60 over 100 times 2100. Again, that's like 60 times 21. 1260. And then I guess divide that by 7. So why not just do a bus stop division? 12 divided by 7, 1, remainder 5, 8. So 1 share, so salesman's share is £180. Then I guess we need to compare if they split it equally between all 10 people. So we would have then 2,100 divided by 10, which is 210. So each person would get £210. And is this equal to 25% more money? That's the question. Well, let's see. Let's do the difference between those is £30 divided by 180. That would be the percentage. 3 out of 18. What does that simplify to? That's 1 in 6, isn't it? So that's not 25%. That's like 16 or so, 16%. I guess we need to work out 25% of of 2100 as well. Well, I guess we could have done this as well. So that will be 25 over 100 times 2100, which would be 25 times 21. $525. Oh gosh, why not just do a long division, long multiplication? 5, 2, 10, yeah, 525. Why was I doubting myself? Okay, so clearly not 25% of the amount. Oh, 25% more money. Sorry. Yeah. Oh, this amount here. We don't need that. Yeah, it's about 16% more, not 25% more. So, sorry, yeah. So then the final step would actually be, you could do it this way, or maybe a simpler way is to do 180 times or plus 25%. So you could find 25% of 180. So 25 over 100 times 180. 25 times 1.8, or, well, a quarter of, actually that'd be easier, wouldn't it? 180 divided by 4. 45. And so therefore 180 plus 25% would equal 225 pounds. So you could compare, rather than doing it this way, which is a bit harder without a calculator, I'd do it this way. Alright. So then just 225 does not equal 210. So no, salesman is incorrect. Alright. Okay, so that was 5 marks for question 3. Then Suraj, sorry about that. There was a ratios question here in terms of, what was that? I think it was question 15. This one here. Do you think this would be helpful? This one on shapes in terms of surface area, height, and volume. Oops. Alright, let's tackle this one. This is the final question I'm going through. Then, gotta go get something to eat and get to bed. Question 15 says, 3 solid shapes, A, B, and C, are similar. The surface area of shape A is 4 centimeters squared. The surface area of shape B is 25 centimeters squared. The ratio of the volume of shape B to the volume of shape C is 27 to 64. Work out the ratio of the height of shape A to the height of shape C. Give your answer in its simplest form. I have a video on that one. June 2017, yeah, I've done that in a video already, Yadoi. Okay, so what's the key to this question? Does anybody know? What's the relationship between similar solid shapes, their height, surface area, and volume? There is a relationship between them. G Ruby says the square root. Yes, so that's the surface area and the heights. What about the volume? Linear scale factor, that's another way of saying it. Yes, linear scale factor. So firstly, we could talk about the ratio of the heights of B and C because we have this ratio of the volumes. So the ratio of the heights in terms of the volume is the cube root of the ratio of the volumes. Okay, so that's our starting point. So the ratio of the heights of B and C, cube root of 27 is 3, the cube root of 64 is 4, so the ratio of those heights will be 3 to 4. Now we have the ratio of the surface areas of A and B, so we can talk about the heights of A and B. With surface areas, it's the square root. So the cube root for the volume, square root for the surface area. This will be the square root of the surface areas, 4 over 25, which is 2 over 5. So let's just talk about the heights now. We have the separate ratios, we need to combine them. So the ratio of A to B equals 2 to 5. The ratio of B to C equals 3 to 4. Now what's the key here to combining these ratios? I want to write the ratios A to B to C. I need to be able to have this B, this ratio belonging to B, to be the same. So I want this and this to be the same. So I can multiply this one by 3. This one by 5, and then I'll have the ratio, well this would turn into 6 to 15. This would turn into 15 to 20. And there's different ways of doing this, combining ratios, but this is generally the way I do it. So look for the lowest common multiple of those two numbers, 5 and 3. And when that number is the same, I can combine those ratios. So A to B to C will be 6 to 15 to 20. And now go back to the question, work out the ratio of the heights of A to the height of C. Sorry, the height of shape A to the height of shape C. And we can just read off this ratio. It will be A to C will equal 6 to 20. And we're not quite finished because we need it in simplest form. Divide by 2, this will be 3 to 10. So final answer there, 3 to 10 for the ratio of the heights of A to C. So the cube root for B to C was because they talked about the volume. So the relationship between heights and volume is actually the cubed root. Another way of writing it is the other way around. So 27 over 64 would equal HB to HC cubed. So just reversing it. One way to think about that is if you look at the edge of a a cube, what's the relationship between the edge of the cube and the volume of that cube? Well, you take that edge and you cube it, right? So finding the volume of a regular cube, if it had an edge of 2, it would be 2 cubed would be 8 centimeters cubed. So that's the idea behind the ratio of the volume and the height. And thanks, Suraj. Glad I could help. Hi, Sean. What's up? Exactly, Ahmad. Exactly. Alright, if there are no more questions, then I think that's it for today. Good luck with the rest of your revision if you are continuing with your homework, or maybe you're taking a break now. What's the time? 7. Oh, it's getting late. Yeah, maybe time for a break. I think if you've been working hard, you deserve a break. Go and watch some YouTube. Go and watch some, I don't know, whatever you kids are into these days. PewDiePie, Mr. Beast. Go and donate to Team Trees. It's a good cause. Plant some trees. And I'll see you next time. See you in the next live stream or the next video. Thanks for tuning in. Catch you later. Bye.